Alright, so that one says manufacturer of bolts has a quality control policy that requires it to destroy any bolts that are more than 4 standard deviations from the mean. The quality control engineer knows that the bolts coming off the assembly line have a mean of 8 centimeters with a standard deviation of 0.05. For what length will the bolts be destroyed? Okay, so for this one, it says 4 standard deviations. So all you got to do is add and subtract 4 standard deviations from 8. So if you pull up Desmos, you can basically just do, I don't know if you got Desmos somewhere. There you go. So the mean was 8, so click 8, and then minus 4 standard deviations, so just put 4 times the standard deviation, which was 0.05, I think. 0.05. And you could use your keyboard, by the way, when you're doing it. And then just press enter. And then now copy that and paste it in and press the plus. Just like scroll on it. Yeah, copy. Press Control C or Command C. When you grab it though, Yeah. Press Control C or Command C. And then go to the next one and press Control V or Command V. I'm not sure how it works on a Mac.
What do you mean go to the next one?
Go to the next, like below it.
Oh, right here?
Yeah. Now press like Command V or Control V. There you go. Now just change the subtraction to plus. You could use your keyboard too. I find it faster to just instead of like using the mouse to click stuff, I just use my keyboard. So here's your answers: 7.8 and 8.2.
Does it matter which one you put?
7.8, 8.2.
Oh yeah, greater.
Yeah.
Greater than 8.2 is greater than 7.8.
Yeah.
2 is greater than 7.2 or 8.7.8.
7.8, 8.2. Actually, the numbers are backwards because it says it'll be destroyed if it's less than.
Oh, they're backwards.
Because it's gonna destroy. They're gonna destroy the bolts if they're too small or too big. So, too big is kind of like you want the bigger number because it says greater than, right?
Right.
And then less than, you would want to put the small number. Does that make sense on that last one?
Yeah. How do you know what to do? Like, I guess you gotta read the question and know just from the question what to do. Because with that, I was just stuck. I just didn't know what to do.
Go to the last question. No, yeah, there you go. So it said, for what lengths will the bolts be destroyed? Well, he said that the question says that they'll destroy the bolts if they're more than 4 standard deviations away from the mean, right?
Right.
So you basically got to find 4 standard deviations away from the mean.
Can you wait one moment, please?
Yeah.
I think.
Yeah, man. It says if it's within. It says that if it's more than 4 standard deviations from the mean. Does that make sense?
Yeah.
Yeah. So 8 centimeters in the center, and then you go out 4 standard deviations. You subtract 4 standard deviations, and you add 4 standard deviations. So anything outside of that area would be rejected because the bolt is either too big or too small.
Got you.
Yeah, it's another one. You want to try this one or?
Explain the meaning of the following percentiles in parts A and B. A, the 10th percentile of the weight of the male's 36 months of age in a certain city is 12.0 kg. B, the 95th percentile of the length of newborn females in a certain city is 53.8 centimeters. Choose the correct answer below. Huh?
Yeah. So, can you increase the height of this window so we can maybe see a little bit, or decrease the size a little bit?
You said decrease the size of the window?
Try
That
to
make it smaller?
No, increase. I want to see more of those choices. There you go. It's a little better. Cool. All right, so 10th percentile, what that means is that, like in this question, it says 12 kilograms. The 36 months doesn't matter for this question, but I guess that's just kind of who we're dealing with. We're dealing with males 36 months of age, so that's what we're talking about. But we're talking about the weight. The weight is what is the 10th percentile. So 12 kilograms is the 10th percentile. And that means that 10% of 36-month-old babies weigh less than 12 kilograms, weigh less than or equal to 12 kilograms. A percentile sort of tells you what percentage, tells you that is heavier than that percent. So a 12-kilogram baby is heavier than 10% of babies, but also lighter than 90% of babies. So that's kind of what a percentile does. So which one of those tells you that? Part A says 10% of 36-month-old males weigh 12 kilograms or more. That's wrong, because that's the upper 10%. Part A would give the upper 10%. Part B says 10% of males weigh 12 kilograms or more. No, we don't want to go or more. We want to go or less. So it's one of C or D. What does C say? 10% of males weigh 12 kilograms or less, and 90% weigh more. That one looks right. What does D say? 10% of, so part C said 10% of males. So but part D, it says 10% of 36-month-old males. So it's got to be D, right? Because in part C, they're just saying all males, but it's really only 36-month-old males. So that was tricky. They're trying to trick you on the difference between C and D, because C and D are really saying the same thing, except that D is more specific on who they're talking about. So yeah, that's why the answer is D.
Gotcha.
Yeah.
So it's basically just asking you to explain this.
Yeah.
Like which one of these match with this?
Yeah, for part A. Now for part B, same thing for part B. See if you can get part B.
Right. Answer below. Born females in certain cities 53.8 kilometers. 9% of females have a 58.3 more, and 5% of newborn females have a length that's less than 50.
So right away we know that A is wrong because it says more than, and percentiles are always less than. So the 95th percentile, it says that it's greater than 95 and less than 5, right? And that one's saying 95% are more. So no, that's wrong. It needs to be less.
So the answer is B.
Okay, but it just says females. Remember, it did that. That's that trick. It wants you to be a little more specific because it's supposed to be newborn.
Oh, newborn females.
Mm-hmm.
Gotcha. So since it's always less than and it's newborn females, the answer is C.
Yeah.
Provide an interpretation of the results. Choose the correct answer below. So, okay. Violent crimes include rape, robbery, assault, and homicide. The following is a summary of the violent crime rate. Violent crimes per 100,000 population for all states of a country in a certain year. Complete part A through D. Provide an interpretation of these results. Choose the correct answer below. So this question is asking for complete the part. Provide an interpretation of each result. I'm not sure what this question is asking, honestly.
Well, it says provide an interpretation, so it wants you to write like a summary of what Q1, Q2, and Q3 mean in the context of the question. So basically summarize the results. So they're giving you the results. They're saying that Q1,
which
Q2,
one?
Q3. Yeah.
Oh, okay, so
They want to make sure you know what Q1 means. Q1 basically means 25th percentile. Q2 is the 50th percentile. Q3 is the 75th percentile. So it's similar to the last question, how we were interpreting percentiles. And now we're just interpreting quartiles.
And the first one's always 25%, the middle's 50, and the last one's 75%.
Yeah. So which one do you think it is? Is it A?
No.
What about B?
25% is 2. It could be so far.
Yeah.
387. That matches. Yeah. It's B.
Yeah. Yeah. That is. Yeah. Good job.
Finally, a correct answer.
Yeah. Determine and interpret the interquartile range. Okay, do you know how
this is what I had a problem with. I know, like, you gotta find. I don't know how to find it. Like, it's confusing. So I need help with this.
The interquartile range is simply Q3 minus Q1. That's all you gotta do. Just take
serious
numbers and subtract. Yeah.
Wow.
That's it.
Do that real quick. So it's Q1 minus Q3. So that's 272.8. 272.8. And how did I get back to the other one?
Go to the right. Yeah, go there.
All right, cool. All right, 529.1. Where's the equal sign? Oops, wait. So that's the answer right there, or did I do something wrong?
That's the answer, but you subtracted wrong. So it's basically the positive of that. You did Q1 minus Q3. You're supposed to do Q3 minus Q1.
Okay.
But it's just, that would just mean that the answer is it's just positive of that answer. So you can copy that 256.2, or you can just plug it in, type it in if you want. But I guess it's 529.1.
Oh. I'm gonna just do it all over.
Yeah. So
So Q3. I need to get a scratch of paper so I don't have to keep doing this, but sorry. 520 what? 529.9.
529.1.
Yeah. My brain is gone now.
272.8.
All right, so this is the answer, 257.3. So 256, excuse me. 256.3. Sheesh. Interpret the range, choose the correct answer below.
Okay, what do you think it is? What is the interquartile range? It's basically...
It's like 68% of it.
No, it's the 50%. Because remember, quartiles are breaking things down into quarters. So the interquartile range would be the middle 50%. So let's see if you can figure it out.
It's a C.
They both say the middle 50% of all observations have a range of. So it's like, oh, they're both saying exactly the same thing. The only difference are those numbers. So my question is, which one of those numbers do you think is right?
Oh. So yeah, it's definitely C.
Yeah. Because that is the interquartile range, right?
I wonder why it's like this. I want to be able to see everything.
You could make it smaller or something, or increase the height of the window.
The height, the bigger the window go, they get all of this stuff, but the actual question doesn't get bigger.
You can't grab the top of the window and pull it up.
This is the whole window right here.
Oh, it doesn't go higher, huh?
Nah. They made it like that on purpose. I mean, like, that's literally how it is. Like,
oh, you have to like decrease. You can decrease the size, then decrease the font a little bit.
Man, negative.
Yeah, that's better.
All right. See, the violent crime rate in a certain state of the country in that year was 1,496. Would this be an outlier? If the crime was 1,496. And so what would I compare this to know if it's an outlier or not? Should I graph it out to see it, or should I just know by reading this?
You got to check the notes. If I wasn't here, I mean, I'm going to tell you how to do it, but you need to do this. You need to know how to do this without me. Do you want me to show you how to find it in the notes, or do you want me to just show you how to do it?
I'll find it in the notes for sure.
Okay, so first we need to figure out what section is this. This is 3.4. So do you know where the Google Drive is?
Yeah.
Yeah, can you go to the Google Drive to 3.4?
Yeah,
I'll show you how to, like, if let's say I wasn't here, I'm gonna show you how to find it. So let's see, you would go to what, home? And then you would go to where? That Google Drive. And then you would go to 3.4, the PDF. Okay. So then you would be like, you kind of need to know the topic of what we're doing. So look at part B. It says interpret percentile. That's what we were doing, right? Remember we were doing that?
You said part B.
And then like number 2 and number 3, that's kind of what we just finished. We were interpreting percentiles. We were interpreting quartiles, right? So, and also the interquartile range. So I guess part 4 says check a set of data for outliers, right?
Mm-hmm.
So that's kind of where we're at right now. The question says, would that be an outlier? So you would have to go all the way down to 4. And let's see, where is it? So you'd have to kind of know how to find it. Let's see, where does it start talking about checking a data set for outliers? Like right there, number 5, right? It says check a set of data for outliers.
Mm-hmm.
So then, boom, that's it. You see how it says lower fence and upper fence? Those would be your formulas that you need to use right now to check whether or not that thing is an outlier.
So you want to make a box?
And you don't need to make that box much. You just need to make that upper fence and that lower fence. Those formulas are important.
Where are the fences at?
See if it says upper fence and lower fence? You see it, right?
Yeah, I do.
Those are the formulas that you need.
So I need to plug these formulas in to get my answer.
Yeah,
Q1,
yeah.
Q3. Well, what is the formula do? Oh, minus 1.5 and then plus 1.5 to get the IQR?
IQR, yeah. The interquartile range.
So wherever the interquartile range is, it depends?
Yeah, we got the interquartile range. Remember, it was like 256.3.
Okay.
So we would have to
Q3. Plug in those. All right.
Yeah, just plug in those formulas, and then those are going to be your fences. And you need to figure out if that data is in the fence or outside of the fence.
All right.
So we have to go back. Where's the problem? So we have the Q1 and the Q3. Now look, it says 1,496. So that's a big number, right?
Yeah.
So we only care about the upper fence. We don't care about the lower fence. We know it's not a lower outlier. It's got to be a bigger outlier because it's a big number compared to like Q1, Q2, and Q3, right?
But doesn't it say it's asking for both, like lower?
Oh, it wants both fences. Yeah. Okay, then okay. Oh wow, this thing is like really helping us because it's saying lower fence and upper fence. So it's kind of like, that's a big clue of what to do, right? It's kind of guiding us here, right?
Mm-hmm.
By saying the lower fence and upper fence. I didn't know it told us that. So that's a hint. That's a huge hint. So yeah, the lower fence. So lower fence is going to be Q1 minus 1.5 times the IQR. So we got Q1. It's 272.8. Yeah. So we can plug in 272.8. Go to your calculator. There's your 272.8. If you want to just delete the negative and the 5. Yeah, there you go. And then go to the right and then just put like minus 1.5 times 256.3. That's your lower fence. Cool. We can copy that. Copy the negative 1. Yeah.
Negative 2?
Yeah, the negative. Yeah, press. See if you got to learn how to copy. Oh, cool. You got it. And because you might be using that on the test, so copy, then go back to the thing, and then put paste. Oh shoot! Hold on, go there. Yeah. So there's command keys. I don't know why. There you go. And I'll go back to Desmos, and then just change the minus. But wait, for the upper fence.
Mm-hmm.
We got to make it plus, but we also got to use Q3 instead of Q1. So just go to the minus sign and change it to plus. over on the left.
Right here.
Yeah, because the formula says plus instead of minus. So we can put a plus right there.
Yeah, hold on. Fuck.
And then get rid of that 272.8. We gotta replace the 272.8. No, not that one. No, leave that. Press Control Z to and then go back to the 272.8. Get rid of that. We gotta put Q3 there now. Q3 was like 529.1. Yeah. So you can go to the left.
29.1.
Yeah.
All right.
So then 913.55. You can copy that. All right, so those are your lower and upper fences, right? You gotta remember that. And then next thing, when you scroll down a little bit, it says, would this be an outlier? And that number 1496 is bigger than 913. So what do you think? Is it an outlier?
Yes.
Yep, so it is. And then there's two reasons why, B or D. Which one do you think it is?
D,
yeah, that one,
it's
right?
greater. No, that's
yeah, that one. There you go. So that's good. That's a good question.
Dividing cards is skewed symmetrically.
Skewed or symmetric? 270 to 280. That's 100. What do you think? That's a tough one. I'm gonna tell you it's symmetric, but I'm gonna tell you why, because this is a little bit tough. The distance from Q1 to Q2 is 100. About 270 to 380, that's about 110. But the difference between Q2 and Q3, that's 380, 480, plus another 50, so it's 150. So it's longer to the right, and there's an outlier on the right. So there's an outlier on the right, and
it's longer.
And that box part is bigger on the right. Yeah.
Makes sense.
Yeah. So I'm thinking it's symmetric. I'm sorry, skewed right, my bad. Skewed right, because, yeah.
The accompanying date results that miles per gallon of a random sample of cars with a 3-cylinder 1.0 liter engine. Compute the Z-score. Okay, good. I need help with Z-score. Compute the Z-score corresponding to the individual who obtained 34.4 miles per gallon.
Okay.
Interpret this result.
That's a good one. That's a good one. That's a good question, man.
Compute the Z-score corresponding to the individual who obtained 34.4 miles per gallon. Interpret this result. Okay. So to find a Z-score, I know it's X minus, is that mu?
Yeah.
Divided by standard deviation.
Yep. Sigma. Yep.
But every time I plug it in, it just don't work out for me.
Okay, first of all, it says that this is a random sample. Do you see the word random in the very first sentence?
Yeah.
So when we get the standard deviation, we're actually going to use S. It's actually going to be X minus X bar divided by S, because it's a random sample. This isn't the population. This is a sample. So when we find the standard deviation, we got to find the regular standard deviation, not the unadjusted one. So the sample standard deviation and not the population standard deviation. So that's a big change. Huh?
I keep getting confused with, getting those mixed up. How do you remember that?
Yeah, I know.
I need to write it down.
That's hard to remember. Like just the regular, remember it by this. The sample standard deviation is used more. So that's the regular standard deviation. And so yeah, if you want to just remember that, like if it's a sample, then it's the regular standard deviation, because the sample is used more often in statistics. We don't really have the population standard deviation.
So with this one, we use the what's it called?
No, we use the regular one because it's a sample. So we just use the standard deviation.
Also, when do you know when to go to bin data and this regular one?
That's if they give grouped data. This is just regular data.
All right, cool. So I was gonna go down to.
No, we don't want the unadjusted one. We don't want the unadjusted one. That's the population standard deviation.
So that's the normal one?
Yeah, that's the population one. I would call the normal one the sample one because, like I said, in statistics we always deal with the sample.
So what will we go to?
Just standard deviation. That's the normal one, the sample one.
Okay.
By the way, it's adjusted. The sample standard deviation is adjusted because you're dividing by n minus 1 and not n. So it's adjusted.
What does that mean? What are you talking about?
Because you know how they say unadjusted, right?
Oh, or adjusted, but
yeah. So I'm trying to explain the word unadjusted to you.
Yeah.
Unadjusted means that they're dividing by just n, so it's the population, and that's a little bit hard to go into, like why they divide by n minus 1. Because in one of them they divide by n minus 1, and that's the sample. But in the population they just divide by n. So I don't want to go deep into that because that's kind of like hard to explain that, but just note that the sample, try to memorize that the sample one is the regular one, the default one, the sample standard deviation. So really, you gotta be reading the question carefully and figure out if it says population or just sample. So back to this, you already got the standard deviation, so you're good. You also want to go to options and get the mean too. So go to options on that box and include the mean.
Oops.
There you go. Cool, so we got all our data for our z-score. Now, we can start plugging in the z-score now. We got the value, right? You can close that data. We got the value, it's 34.4. So it's going to be 34.4 minus the mean.
Wait, hold on. Where's the 34.4 come from?
It's given right there in part A.
Right here. Okay,
Yeah.
so so that's X.
Yeah, that's X.
All right, so.
So if you want to do this in StatCrunch, you can do it in StatCrunch, but I prefer Desmos.
Right.
Okay, so the problem with going to Desmos for you is that for some reason everything is it's on different desktops, but
it was 34 point what?
Well, go back to the other one.
Right, let me first. Oh shoot, delete all that. And
34.4, right, 34.4.
Minus, and then you're gonna go back to.
So copy the mean, just grab it if you want, just copy it. Yeah. No, why you round it? Copy the whole thing. We don't want to round stuff until the end. Well, you didn't need those parentheses though. Press Control Z to undo what you did. Okay, there you go. Oh wait, that's good, right?
Oh, I need one more right here.
Yeah.
And this, and then just copy and paste this.
Mm-hmm. Okay, there's your z-score. So just now you want to round that to 2 decimal places. So can you round it?
So it's asking for this, but since this is 7, does it go up to 1?
Yeah, that's right. But you gotta get rid of all that other stuff.
Yeah.
There you go. And it indicates that the data value is that many standard deviations.
Blank standard deviations. What is this?
That's just your z-score. That's just your z-score. That's what a z-score is. So you put 1.31 right there.
You put what right here?
1.31.
How do I know to put that right there? Oh, the same thing?
That's what it means. You need to understand what a z-score is. It's the definition. A z-score is the number of standard deviations above the mean. This is the definition of a z-score. So you kind of have to memorize this definition. That's what a z-score is. It's saying the z-score is 1.31, and that means that the value is 1.31 standard deviations above the mean, because it's a positive z-score.
Okay.
Yeah.
Oh, got you.
Yeah.
Because the fine of the z-score is defined like the.
Mm-hmm.
Got you.
Yep.
So.
Hold on, see what did it do wrong. Let's go type integers or decimals rounded to 2 decimal places as needed. Okay. 34.4 or 1.0. 34.4 minus 38. Go back to the thing again. 30. Oh wait, where's our data? We need to go to StatCrunch. Can you go to StatCrunch again?
StatCrunch.
Yeah, just go back to where we just were.
Oh, okay.
Oh yeah, open that, yeah. I want to double check the mean and the standard deviation. We did stat, summary stats, columns. Clicked variable 1, we got the mean and standard deviation.
And what else is the mean?
Yeah. $38.979167. And that's what we used, right?
Right. I think, let me check. Oh yeah. Let me go to Desmos.
We'll pull that guy up. 38.979167 and see.
And 35.
Oh, we didn't put the negative in.
35 and 38. One of them should be negative.
Yeah, it's negative.
This one?
No, the z-score is negative.
Which one's the z-score? This one down here?
No, the number on the right, negative 1.3.
Oh.
How did we not copy that? I thought we, no, just go back and just input a negative. We don't need to recopy it because we already copied the number correctly.
So this is just negative?
Yeah.
So the what's called changes too.
Yeah.
So it's a below.
Yeah.
Below.
Yeah. Okay, let's see. Indicates that the data value is okay. Get rid of the dang. This is tricky. I can see how this could be tricky. Get rid of the negative. The second negative. Because we're saying that it's 1.31 standard deviations below the mean. That doesn't need to be negative because we're saying below, right?
Mm-hmm.
That's pretty tricky.
That is very tricky.
People are gonna get that wrong. I'm glad we have this video now. I'm gonna show this to the class.
Yeah, just ask for the wait. Let me see. So are they asking for?
Now they just want the quartiles. That's easy to get on StatCrunch.
Oh, okay. Do we go back to StatCrunch?
Which is right there. Yeah. Just go to options, edit, throw in the quartiles. Remember, we need the median because that's Q2. So Q1, Q1, median, and Q3. Go down a little bit, it's right there.
Oh, damn.
You don't need the mean. You don't need the mean and standard deviation though. Just Q1, Q2, Q3. There you go.
All right, so now we have that. And I just ask for that and just unplug it because it's right there, huh?
Yeah, that's it.
So Q1, let me just copy and paste, be faster.
Cool. You got it?
Yeah. You know what I'm saying? Compute and interpret the interquartile, what?
Interquartile range.
Interquartile range, IQR. Select the correct choice below and fill in the answer box to complete your choice type.
So remember what the IQR is. Can you compute it? Do you know how to get it?
Remember what the IQR is?
Yeah, we did it. Remember how we got it? Do you remember how we subtracted for it or no?
No.
It's Q3 minus Q1. If you go back to those notes, you'll see all of it is in that notes. You're looking for the interquartile range. It should in the notes it should say that it's Q3 minus Q1. If you want to just verify, it should be in those notes. So look for the interquartile range formula. Should be down in 4 or 5. There it is. Interquartile range is Q3 minus Q1. So that's how you find it.
Perfect. All right, so compute the interquartile range, select correct answer below.
Well, by the way, I'll show you something cool. If you go to the data, StatCrunch gives you the interquartile range, so you don't even need to find it. Click, yeah. Check this out. Go to options, edit, and IQR. See? On the bottom, you see it?
Mm.
So we don't even need to find it. We could just have StatCrunch find it for us.
It's time to go.
4.25. There you go.
It's time to go.
The observation between either lower.
Which
What is
one?
this question asked again? Is interquartile range is 4.25.5. It
What is
is
the
range
range
of since it's 4.25, it's in the range of 4.25. I'm not sure.
What is the? Oh, go to the notes real quick. It should be in there. What does it do? Scroll down just a little. Oh wait, just higher, a little bit higher. Up a little bit. Do you see that? That sentence right there. IQR is the what?
Width of the middle, 50% of the data. Cool. Definitely know that.
Yeah.
The range of 4.25. So it's 50%.
Yeah.
Since it's the IQR, proven IQR.
Yep.
Determine the lower and the upper fence. There any outliers. To determine the lower and the upper fence. Let me go back to the notes.
I wonder if StatCrunch gives these, but we should know the formula though. If you go down a little bit. Right there.
So right here, IQR, just plug in IQR with the Q1
Yeah.
and IQR. All right.
But I'm curious, I'd be very curious to see if StatCrunch gave that. If you click the data again.
All right.
I'm really curious if it gives the fences. If you scroll down. I don't see it. Maybe it doesn't give it. That'd be interesting if it did. Okay, so 36.85 was our Q1. Go try it on Desmos, because I don't know, maybe we'll get a different answer. Try it on Desmos. Because I wasn't sure about using that thing. I'm pretty sure we did it right, but let's just check Desmos. So 36.85 is Q1. Minus 1.5 times the interquartile range. What was the IQR again? 4.25 or something?
Yeah, I think so. 4.25.
Okay. Yeah, just press that. So 30.475. See, we were too precise, right?
Yeah.
Yeah. Because we put more precision on our mean and standard deviation. But no, I think we may have done it wrong, because what did they get?
I already deleted it.
Yeah, let's see what they get. Was it 34.25? Press paste. Yeah, so our number was off for some reason. We probably used the wrong notation or something. Because look, we have 45.35, but when you go back to Desmos and change the subtraction to plus, just change this. Oh, actually, we got to change this. Oh, change the subtraction to plus. We may have forgot to change Q1 to Q3. Now go to 36.85. We have to put in Q3 now for the upper fence. I wonder if we forgot to do that when we did it last. We may have forgot to do that. Oh, and I think we also used the mean instead of Q1 and Q3. We must have made a mistake when we did it on that StatCrunch. I think we used the mean and we didn't use Q1 and Q3. Okay. Got it. So you have to switch out that. Did you put the Q3 instead of 36.25? Yeah, you got to use 41.1. See? No, not there. The front. In the front. Yeah, that should be Q3 instead of Q1. 41.1. That's your upper fence. Yeah, we did that wrong. We used the mean. I just realized earlier. Wait, what? Wait, what? Okay. Yeah. Now it says, are there any outliers? Good question. Do you know how to answer that?
Can you hear me?
Yeah, I can hear you now.
Said I was gonna look at the notes, but before I look at the notes, I was gonna say since it's a formula to get it, ain't it? Outlier?
No, for the outliers.
Are we looking at 4.2? Because I know these are the fences, the 30 and the 47.
We already have the fences. Those are the boundary points. Now we need to see if there's any points outside of the boundaries. Like, for instance, smaller. So we need to look at the data actually to see if any data is smaller than the lower fence or bigger than the upper fence.
So literally
that's how you're supposed to do that. There's a little, let's see, there's a trick that I might show you. One trick is to just make a box plot. Let's see, what's a good, open it. There's a couple things you can do. You can put the data in order and then check out well, actually, is the data in order? It is in order. The data is already in order. But the best trick is to make a box plot of the data. Just click variable 1, press compute, and it'll tell you if there's an outlier, because there'll be a star. See, there's a star. So we already know there's an outlier because of the box plot, right?
Right.
But you have to prove that mathematically on the test. You have to say yes because it's greater than the upper fence, right?
Right.
So you go back to the question, and you, obviously, no way, go click that dot, like hover over that dot. And then since nothing appears, 48.9. So that's the outlier. So the outlier is 48.9. Yeah. That's like a little trick.
That was pretty helpful. I'm definitely hopefully I can remember that.
Yeah.
Interpret the quartiles. The first is Q1. Oh, so to find Q1, you gotta put it in here.
Yep.
StatCrunch. You gonna pull up all the Qs? Q1, Q2, and Q3?
But not for Q1. They only want Q1 right now. So, but we'll need those other Qs probably later. In the next part, like in the next part, they'll probably ask for it. -0.02. Yep. Did you ever figure out how to find the mean of that group's data or no?
The mean of group data?
Yeah, you sent me a question. You emailed me a question that was talking about like groups data. And you were saying you couldn't find the mean because you were having a round off error or something like that?
I'm not sure.
Okay.
What just happened?
Not sure.
Sheesh.
Technology.
So this question says, interpret the quartiles, choose the correct answer below. So when they ask to interpret the quartiles, that means they want Q1, 2, and 3. They want you to tell you like,
yeah, they want you to say 25% is blah, 50% blah, 75% blah, you know?
But you gotta know what the quartiles are first.
Yeah,
right?
yeah, you gotta know what they are probably. Although, yeah, did they have you put them in or no?
They're right here, I think.
Okay.
So I'm about to figure them out by doing this, right?
Yeah.
Alright. And then just put all of them in there, and they're going to eventually ask for all 3.
Probably. And the median, not the mean. Do you need the median?
Yeah, I'll just ask them to get I was looking for the median.
There you go.
Alright, which one they ask for first?
I'm trying to get Sequoia to be an embedded tutor for this class.
Yeah, she's pretty good.
Yeah.
I wouldn't even be this far if it wasn't for her.
Okay.
Alright, so they're asking the first quartile is the lower bound of plausible monthly returns. So the first
look,
quartile.
none of those numbers. Hold on, I don't think we need numbers right now.
Okay.
Right? Because it's not given any. There's no number entry anywhere. It just says interpret them. It says the first quartile is the lower bound of plausible monthly returns, and that's wrong. What about B? All monthly returns within one standard deviation of the mean are contained in the first quartile. C, the first quartile is 1 standard deviation below the mean. D, of the monthly returns, 25% are less than or equal to. Yeah. Right?
All right.
There you go. Check the data set for outliers. So you know how to do that, right? Checking for outliers.
Check the data set for outliers.
Remember, we had to
The
find
box plot.
It's all that stuff. Yeah, it's the box
The box
plot.
plot. Yeah, and then
Yeah.
you click on it. Yeah, I understand. See, I could definitely finish this.
Yeah.
I feel like I get it pretty good.
Cool.
Worked on the Z score too, huh? Yep. I need help with that.
Yeah, you got it, man. You got it all.
Feeling a little better confident. I was about to throw in the towel this time. I was like, bro, I don't know if I can do this. I don't know. I literally 4 problems took me like 2 hours this morning. I'm like, bro, I literally just spent 2 hours on.
Well, I'm glad you emailed me. Just keep emailing me questions. I'll send you like videos if I have them for those questions, or I'll make a video like we're doing here. We're making a video. So like I want to be able to send videos to people on anything that they need help with, you know?
Yeah.
So if I don't have a video of it, I'll make one, you know?
Facts.